Okay, so what we are doing today is actually starting the section B discussion of paper 2. So the first thing is what we are going to do is section B, and the chosen question was actually question 8. So if you see, right, this question, first you have to analyze chapter, of course. Anything in maths, when you see a question, you have to think what chapter comes from. Then only all the formulas will come inside. Okay, so let me see. Okay, so if I tell differentiation, right, what are a few keywords that come to your mind? Like anything, like you can just say one word or anything about this topic. Yeah, okay, very good. That is always that whenever we see the word differentiation, we think about dy dx, isn't it? Or it can be anything. It just depends which what subject of the formula and what you express it into. If it's a equals something something x, means it's dA over dx. So you have to take the subject of the formula, divide by what is the variable we use to express the subject of the formula. Okay, so that's one thing. Any other keywords before I bring out the topic? First principle, okay, good. And it's also a popular exam question also. So yeah, we should be prepared for it about for SPM. Hope it's in section B That's the only thing, so that we can choose it. Okay, so first I will show the question, then we will get the idea like how to solve first. We see the question first. Okay, so this is the one. Okay, so can see, right, Kuan?
Yeah.
Okay, so here I do. Okay, so the question actually said it shows a trapezium PQRST and QS is parallel to PT. Okay, so whenever they say like this kind of things like parallel, right, you can actually mark like this on the diagram just to give you like a hint. It can be used especially in coordinate geometry. Usually they'll tell like this line has same gradient as this, means it's parallel. So we use this sign to show that it's parallel. Okay, so next thing, trapezium. So definitely you must know the formula. This whole thing is trapezium from here to here to here. Okay, so now we analyze the question. So always when they give you values like this, right, make sure you put it inside the diagram. So TR, they said it's 26. So this whole length equals 26. And then QS is X. And SR is 2X. So immediately when you see from here, what can you express? Another length, like any side.
TS.
Yeah, okay, so what it is? What is it? Oh my god.
26 minus 2x.
Yeah. Okay, so that's the first thing. And then let me see. Anything else? This one should be X also, I think. This one. And then this one also is 26 minus 2x. Okay, so the one we can hold on first. We don't need to write all this actually, but just to analyze. Okay, so first question, they say state the area of PQST. So PQST is actually what shape?
I'm sorry.
PQST is what shape?
It's, I don't think it's a square.
Yeah, correct. It's not a square actually because you see here, right?
Yeah,
Different lengths. So
it's a rectangle.
yeah, correct. So the formula we use for rectangle is
Hmm.
actually length times width, lah, same as square. Lah. So actually you see, right? It's actually state only. So it's
In
like
terms
quite
of
a simple working.
x.
Lah. That's why they use the word state. Yeah, correct. So we just need to show the 26 minus 2x times x only. Lah. That's the basic thing. Okay, and then that is your mark already. So next, when they say maximum area, what is our assumption?
Maximum area should be like the maximum value the x can be lah.
Yeah, correct. So what will we assume?
Um, we should assume that the area should be when when
Hmm,
the area is maximum, we must assume that
the symbol, remember.
more than wait.
Then it's differentiation, don't have the modern thing. Oh, the one you're talking about maximum point, right? Modern or zero.
Oh yeah, but this is
Hmm,
area.
yeah.
Wait, is it d2y over dx square?
No, that one is point. Don't get confused. That one only
Oh,
is a graph. This one
yeah.
is D2y. Just put here, just in case. Usually in this kind of question where I got no graph, the maximum will go is d power 1 only. Usually.
Hmm.
So what will be the assumption?
Um, I'm not sure.
Remember this one, dA over dx is 0. There's maximum.
dA over dx is more than 0.
Equal.
Wait,
So this,
I don't understand.
oh wait, from here what you'll get, if you put dA over dx is 0 means what value you will be getting down here? Like what variable
The
equal?
dx would be 0.
Yeah, correct. So means you'll get x equals to some value lah. Let's say 4 lah. Anything. So why we do this assumption is actually because of the keyword maximum. It can also be minimum, dA over dx is 0. As long they mention maximum, minimum, or sometimes they say least area also. So least area means what we are finding on top there. Like you see, they said area, right? So
Yeah.
this is the dA. Lah. I use A to represent area. Lah. And then you see all the variables here they give is x, right?
Uh,
So I put down here dx equals 0.
so the d actually means like difference in x, right? Oh,
Yeah, you can say that also. Can You can understand it in that way. Lah.
uh, I am still confused.
About which one?
Like the dA over dx part equaling to 0. Can
Hmm.
you like repeat again? Let me interpret it again.
Okay. So this one you are finding here, right? They said area of PQST, right? So you already found the area equals something, right?
Mm,
So now what you are basically doing is you want to find the x value that can get you the maximum a value.
okay.
Uh, so that's why we put this sign lah, like dy over dx, right?
Mm.
Sometimes you will say dy over dx is 0, right? For a turning point, remember?
Oh, yeah, it's because of the
That part, yeah,
maximum.
this
Okay,
one.
I understand now.
This one just turning point lah. We never consider max or minimum yet. If max or minimum is this part lah, this point here.
So when we are doing this is equals to 0, we will get two value lah. One is maximum, one is minimum.
Can also.
I
But
mean,
in this
same thing
case,
for
like
area,
this,
right?
huh?
Same thing for area, what? We'll get one for maximum and minimum, but then we'll get one positive, negative. So we just reject the negative. Is it something like that?
It depends. If the equation comes to quadratic after you differentiate, then you might have two values lah. If it's
Ah, yeah lah.
just x power 1, right, means you have no negative value. It will only be
Oh
one
yeah.
answer.
Okay, I got it now.
Yeah. Usually area is power 2, right? I mean, wait,
Mm.
let me see. Yeah. The equation, yeah, I got one variable is power 2. So the differentiated equation will be all x to power 1 lah, the maximum. So you only get 1x value like this. Okay?
Okay.
Yeah. So this actually is considered easy lah up till this part, up till here. This one is a bit challenging, the B part, because it's quite long actually. Let me see. Well, should I go to this? I think we talk about the topic first lah. Better not go to this. Then understand from the whiteboard. Okay, so now we go to summary of a basically. So okay, how should I start this? Okay, let's start with the chapter name itself. Differentiation, right? So what can you actually analyze from this word differentiation? Like not mathematically lah, like English way.
Difference.
Yes, correct. So this is actually one important thing that you can notice. Let's say I have an equation y equals 3x squared plus 8x minus 4. This is quadratic form, right? So when you do dy over dx, you will get 6x plus 8. So you see there is a difference between these two. That's why we call it differentiation process. Means the power is different and also this constant is not here. So the difference actually comes from two parts. If you want to divide the difference, okay, so the difference comes from the x power and also there is no constant. Constant I mean by like this number here. Number 4 is absent already. So when you do the opposite of differentiation, which is integration, right? Not from here. Let me do from here. Okay, so let's say I want to integrate this one, right? Integrate dy over dx with respect to dx. So we will get back 6x power, okay? Oh, this one is, I thought power 0. 6x squared over 2. It's an indefinite integral, because got no limits here. Empty. So then you plus 8x, then you plus c. So you will get 3x squared plus 8x plus c. So this is the reason why we actually add the plus c in the integration. Because we cannot expect here will be 0. See? So we add the c here. If we don't add the c, means we'll just get 3x squared plus 8x. Means we assume there is no constant at the back here. So this is the difference. You can see here. Okay. So any other thing? Differentiation. Okay, so difference is a good keyword actually. So this one is a good way to remember. That's why another thing. So first we practice on how to read the symbols. That's a basic. Okay, so far.
Yeah.
Okay, so let's say we have a thing like dy over dx. Pronounce it for me nicely.
Dy over dx.
Very good. So if they give you oral test for NMAX, you'll pass with flying colors. Definitely. Okay, so what is this thing symbol meaning is actually differentiate y with respect to x. So this is how you say it. Like usually we will just say dy over dx equals 6x minus 8, let's say. But actually what they're actually telling is differentiate with y respect to x, you will get something like 6x minus 8. This is the thing. So this is the written form, this is the equation form. So that's the only difference. So let's say I give you d2y over dx2. So how will you read it in terms of word form?
Differentiate twice
Yeah.
y with respect to x square.
Yeah, correct.
Oh,
Okay,
correct.
good. Yeah. These two actually means differentiate twice. That's why we don't put dy square. Dy square is wrong. Sometimes people will get confused. Dy square is actually wrong. And there's also no such thing as dy over dx square. Because you might think you want to do these 2 times what? So dy over dx times dy over dx, you get dy over dx square. So put this as not equal. It should be this way. So it's a differentiate twice y with respect to x square. Okay. So let me see. Okay, can you understand like that? Okay, so another example, dh over dr. I give you the what does it mean? Where h is equal to height of a cylinder and r is the radius. So how will you read it?
Difference of height with respect to radius.
Yes, correct. So you get the thing already now. Differentiate height with respect to radius. So sometimes this is the thing you need to form when we apply something like chain rule. The thing of, let's say, dA over dr. Yeah, this part equals dA over dt times dt over dr. So we need to know how to actually, because question won't give you like dH over dr, is what they'll tell you height and radius. They'll tell you physical quantities. So you need to interpret these two things into a sign like this. So this is why we have to know what is the word, how you tell it in words. Okay. So yeah, this is the thing. Now we go to the proper topic on differentiation. Actually, quite a long thing. And also they like to come up with a lot of like difficult questions with these things. They relate to 3D shapes usually, like how we saw in our exam. So that's why sometimes you need to master the lower form formulas also, like simple things, surface area of cylinder, surface area of cone, volume of something like that. Because the one all is not provided, what is your lower form maths knowledge. So that's where we apply it to add maths. Okay. So that all okay for you, nothing. So now why you laughing?
No.
Simple thing, what? Okay, so
Still got place to improve.
yeah, so okay, so now we go to idea of limits. They also come up with questions, this one. So I'll just practice with some examples, anything. Okay, let's say I have an equation like this. Fx is 2 over 3 minus x. You always notice, right, at the side here, they give you a condition where x cannot be equal to 3. Something like a limit, I would say.
Yeah.
So that you don't get 2 over 0, which is infinity. Ayyo. I cannot draw straight one. I have to draw like this. Okay, so yeah, this is the thing. Another example will be your reciprocal graph, if you remember. The good way to show about this thing. So you have the equation like y equals 1 over x, right? So let's say x is here, y is here, 0. The graph, if you remember on this side, okay, I do a bigger one. I involve all four quadrants. So if this side will come something like this, there you go. Not that accurate. Okay, lah. Then this one something like this. This one something like this. This one something like this. So yeah, it will never join here like this. Form like a shape like that. It won't join. This is what we relate to an idea of limits. Means the graph
It
you cannot
will
touch
it will
on
get
the
close
x-axis.
but never touch.
Yeah, very good. So you see here will continue going up. Something like tangent graph lah. Here will go side, side, side. Here's a side, and here also will continue going down. So yeah.
So never touch the axis or both y and x axis lah.
Yeah, it won't touch. Means it goes to infinity lah, basically. So that's why we have this thing called idea of limits lah. So the question is basically we substitute the limit into the x value lah, then we find the value of the limit.
Hmm.
So
Hmm.
one good lesson from this graph, a good life lesson. Nothing about maths lah. So sometimes in life you must keep going. Don't be distracted by obstacles. Obstacle in this case is your x-axis and y-axis.
Lol.
Don't touch them. Don't make them touch. And it's important lah in like what the context now where we are close to the final one.
Yeah.
So this is the life lesson of the day. Random idea lah.
Very relatable.
See? That's why sometimes you need to relate a lot of things to understand the subject. You can't just look it as a subject by itself. I mean the topic lah. You have to see it from
Well,
different views.
you can't do that for Sijara.
Of course. But can also lah. It depends whether you are good at using acronyms and all those stuff lah. That's another way to relate lah. Not in terms of like relating to life, but in a short form lah. Okay. So now we go to we try some examples lah of idea of limits. So let's say we have everything 2 over cert x minus 2. So let's say the limit is x goes to 2. Okay, wait, let me think. I use textbook example better lah. Let's see. Quite difficult one. Okay, this one. Let's say we have cert x plus 1 minus 1. Minus 1 over x. So they say the limit is x goes to 0. So first question is, can you directly sub this x is 0 inside here?
Cannot.
Correct. Because if 0 here means infinity.
Infinity.
Yeah. So alternative method is we need to know how to modify this thing. That's the only way you can solve, because you cannot do anything from here directly. You'll still get infinity. Okay, so what you actually do is you remember your search chapter. So that's why you see all the chapters are related in a way. You see, differentiation can involve third knowledge. So you need to know your
Yeah.
complications. always when you see surds, you want to like eliminate it, always think of conjugate. Like, there's no other way. So that's the basic thing.
It's times by the same denominator but with the plus symbol, right?
Yeah, very good. Correct. So what we usually do in conjugate surds is we will change the sign. If it's negative, we put positive. No? Sometimes the surd will be down here. So we do the same thing. Either down is the same thing. So x plus 1 over x times, it's not minus. Then here we put plus. So the difference is the plus here. Plus 1 over x. No, not 1 over x. Over surd x plus 1.
Yeah, same thing.
Yeah. So whenever you modify your equation, you must also remember whenever you times here, this value must be equal to 1. So that is fair. We are not doing anything to the equation as the overall. Because if we times something that has a value here, means we are modifying the originality of the question. Like chiplak. Okay. So it must be pure and original in maths. So next thing is, yeah, this thing. So this form is very familiar, right? And we times this two. Negative here, positive here, like quadratic, something. So we must remember the format. Like if you cannot remember, it's okay. So we just do it slowly, one by one. No harm, what? Like this, like this. So just to avoid careless mistakes in those pressurized situations. Okay. So we will get, after we do all the x plus 1 minus 1. So this one, why x plus 1 is because surd times surd, you will always get
the numbers inside.
Yeah, correct. Because is wait, let me think. Sometimes you forget the surd rule. What I do is so
in this
you try in your calculator. Let's say we forget the surd rule or something we just put a random number with the same format as this. You will see your answer is still 3. So from there we can deduce that we take x plus 1 only. So don't panic if you forget the formula suddenly. Try with random numbers and you'll still get this one. So this is the technique also I use. Because a lot of formulas to remember what mathematics, and not all is given. Okay, so this one when I times some plus surd x plus 1 minus surd x plus 1, I will get 0. So this is the format. The format is, can I say this is a square minus b? But there's no square here, something like that. A square minus b, something like that.
Square minus b.
Yeah, can't apply here because you see, right, you actually take the content.
Yeah.
It's not like quadratic. So just do it normally. So you will get here minus 1. Minus 1 times 1 minus 1. And then we expand from here. So this one with
or you can do like a square minus b square.
X square minus?
A square minus b square.
Yeah, correct. So this is the form. Because b square, 1 square, you still get 1. So yeah, that's a good way. So this is the form I remember now. Okay. So good job. So this one is here. So this one we copy back. Don't try to expand this.
Okay.
Because always what you want to do in maths is you want to cancel the top and bottom usually. So you'll get x over surd x plus 1 plus 1. So suddenly you realize something. These two you can cut. So that's why we always maintain the surd here. And don't expand this variable inside. Don't do this one. Because you'll make your equation more complex. Anything you expand means it's getting more complex, in other words. So you get 1 over surd x plus 1 plus 1. So from here, you can use your limit. So they say limit 0, right? So we put the 0 inside here, inside the x. So you'll get 1 over surd 0 plus 1 plus 1. So we'll get 1 over surd 1 plus 1. So here, ayo, no place for it.
It's fine.
My usual method: 1/1 plus 1, 1/2. Done. As long as you don't get something infinity, means your answer should be correct. So this is probably, I think, the toughest they can go for idea of limits. It's usually very low marks question only. It's usually in paper 1, if you realize.
Yeah. Rarely in paper 2.
Paper 2 got what?
Very rarely.
Really. So as long as you remember how to go about it, then I think should be okay. It's all about the steps you take.
Mm.
Next one is first principle. That one's another famous thing. That one, so you must remember steps. Or else we won't know how to do already. So the limits, okay. Yeah, we're going straight to first principle. Okay, so first principle. Don't confuse this with first derivative, first of all. This is not same. In terms of the, wait, let me try to tell it out. Oh my god. Derivative. How? Derivative. Okay. So in terms of the stats, it's different. Similarities first. We do similarities and differences. So similarities is both will give the same answer. Both should, I'll tell should give the same answer. That's how we use in maths. What you can use many ways, but we lead to the same answer. So that's what method in the end is your answer. Mostly in maths, in maths they will see you're working one by one. That's why
So
maths.
usually it's like they give you the first derivative and then they ask you to prove it through first principle, right?
Yeah. Usually they'll give you like y equals like let's say 2x squared. Then they ask you first principle.
Or they will give you that the dy dx is 4x and I ask you to prove.
Yeah, can also correct. Yeah, so that's one more way. So use first principle here also. So usually this is a longer question. So one way for you to check is use your normal dy dx. So this one if you expect to get as 4x, right? So from there you use your first principle. And then see whether it tallies with your dy over dx equals 4x or not. See whether it tally or not. So that's one way to check whether your first principle actually you got it right or not. Okay. So actually first principle also you see right. You must be strong in your simultaneous. Because it involves simultaneous equations. So you see another chapter is related. Yeah, elimination, correct. So usually the method we use here is elimination. Substitution, I don't think so. It's more complicated. So yeah, remember elimination method. So I'll give you a situation. So let's say if y equals to fx, and then dy over dx equals to limit. So this is what they told in the textbook. This is what we usually write in the exam when we want to show that the first principle, right? We'll add that delta y to the y here. And then we make an assumption here, delta x will approach 0. This is kind of like a limit. Means they're saying the approximate change in x approaches 0. So they want to find the value from that. So when we use delta, remember it's approximate change. We will see that in a different type of question also actually. Approximate changes. So this one represents slight changes, I would say. One way, if you forget what is delta x, is recall your chemistry, lah. Remember this Mickey Mouse said it's sort of balik. Remember the water molecule? Yeah. So we usually say this one is delta positive, delta negative, right?
Yeah.
So what this is getting here, lah. The approximate means slightly. That's why we say approximate. Slightly positive. Electropositive, lah.
Oh.
So this is your kind of your backup, lah. You forget what the sign represents suddenly in the exam. So think about this water molecule, lah. Okay?
So it explains about slight changes, lah.
Huh?
It explains about slight changes, lah, in the X.
Yeah, correct. Approximate or slight changes.
Okay. I'm clear.
What?
No. I said I'm clear.
Wow, I'm so happy.
That.
Okay, so they say delta y is small change in y, and delta x
Oh, here it is.
small change in x. So this one is just for your reference, lah, from here. They express to here. So this is what they represent, lah. So now we will go straight to a question, lah. We apply our knowledge. So this is about first principle. Sometimes if you realize, right, the longer the question is, the better it is actually. Do you think like that?
Why?
Because more info is given.
Oh.
Sometimes when the question very short, right, you crack your head more because you don't have info to sub or relate. Like, let's say, proving questions, lah. Prove that this equals to this. So
I'm pretty sure proving questions, they won't let you have it so easy, right?
exactly, yeah. And especially trigo, lah. You
Yeah,
realize.
especially Trigo.
Yeah.
Trigo's never longer.
This question got proving. Let me think. This one won't have proving, I think. Differentiation. I don't think so.
No, they give you like what I said just now, the first principle.
Yeah.
They give you the derivative. That's one of the proving lah. Other than
Yeah,
that, I'm
it's
not
sort
sure.
of proving. Because we already know what dy over dx is, so we use another way to get its value, lah. So it's not a proving. So let's try the question. You want hard one or easy one?
Let's do two. One easy and one hard.
Okay. Okay, I divide easy, hard. So let's say the easy one is this one. Y equals 3x. Usually when you have a lower power means it's easier to solve it than a higher power of x. So what they make it from easy to hard is they actually increase this power. So that it makes it more, when you expand, right, it will come to a
Increase
higher
the
power.
power and then also fractions.
Yeah, fraction, very good. Usually, that's how they make it complicated, especially in product and quotient rule. That's the thing.
Yeah, oh my god.
That one actually they can also ask to prove sometimes. They can, if they give you like a y equation, then ask for you for.
How can you prove a quotient rule?
No, I mean the value of the equation. Let's say y is 3x plus 8, then they say dy over dx is something. Then they ask you to prove it using quotient rule. That's something like that. They specify the method.
Oh, I see.
So kind of a proving also. Other than that, I don't think so. You can show in the textbook also actually how they get quotient rule. I think so. Because sometimes the things in the textbook can come out.
Oh.
Yeah, they didn't show how to get it. No. So yeah, safe lah. It won't come in SPM. Can assure.
Hmm.
Yes, you saw one trial paper, right? It actually came what? Prove the quadratic formula thing I sent in the group. I
Oh
think.
God.
Yeah, they asked to prove by using completing the square or something. Because that one is in the textbook, so they can ask.
Wait.
So
How did they do it?
how to do it?
Hmm.
Use the follow textbook method lah. Basically, just read up on that section.
Hmm. Okay.
I don't want to bring quadratic inside here, right?
No, please don't. Thank you.
If I confuse further.
Hmm.
So let's say this is the equation, right? So let's say y equals
Hello. Bhuvan, your internet.
yeah, yeah, wait.
Yo, yo, yo. Actually, I have to go already.
Huh?
I have to go already.
So fast, huh?
Yeah.
How long? Now?
Yeah.
Now I let you go first.
Okay, okay. The questions, the what was it? The just now the proving one.
Yeah.
Can you do that and then take picture? Send in the
Yeah,
group.
can you can the first principle.
For the easy and okay, easy. I don't think need already lah. But
Yeah,
if
the
you
hard
want,
one.
if you want, you can do for your mentees. Then just do the hard
Yeah.
one lah.
Okay.
Okay. Thank you, Dave.
Okay.
Sorry.
See
Bye
you.
bye.
Okay. Okay, so we will continue from here. So the question was actually the easy one. So the easy level of differentiation using first principle. So what we are going to do is delta y equals to, we have to create a separate equation from here. So I will add y plus delta y equals to 3. And then from there, we have to add a delta x here also. Okay, so this is the first thing. So now we have to try to eliminate some terms from here. So we have to see which term can we eliminate from this equation. So if we see, right, if I expand this, we will get y plus delta y is 3x plus 3 delta x. So first equation, second equation, and then you will see here y. Eliminate it. So we're using elimination now here practically. Well, look who's here. Okay. Hello.
Oh, hello.
Kuan
Wait, no
went
one
out
else
this
here.
time. Huh?
Oh, no
No,
one else
Kuan just
here.
left. Kuan just left. So I just continuing to
Okay.
finish it up lah.
Okay.
So you can respond lah. So from here, now we are doing first principle actually. Here, this is the question. And then we create a second equation, right? First principle. So now we solving using the try to get the answer. So from here we will get delta y equals 3 delta x. Because from here, right, we do 2 minus 1, the 3x will be cut off. Here also cut off. Y also cut off. Y minus y is 0. So we will get delta y is 3 delta x. So from here directly we can already find delta y over delta x is 3. And from this relationship, we also know from here, right, dy over dx is 3. So that's why from here we came up with a formula that dy over dx is equivalent to delta y over delta x. You always use this symbol here. We won't put equal directly. So because it has the same values. So that's why we came up with this relationship. And it will be useful in approximate changes part. This is the approximate change. Approx change. So that's the part where we show it. Okay, so this is the easy level type of differentiation question. So we go to the hard one. Hard one means we increase the power. 3x cubed. Okay, so you want to try? Ryan,
Hello, hello, yeah.
you want to
Try
try?
what
First
differentiate that
principle.
according. Okay. Y
First
equals
principle.
3x cube, is it?
Cube. Yeah.
Okay.
Actually, you know the answer already directly, but we need to show the steps. That's the thing.
Oh yeah.
Oh, this one is long.
Okay. So y equals to 3x cube, and then we just plus dy and then add dx cube. Expand 3. Oh, we must expand one by one. Okay. So plus 2
Yeah.
dx, 2x dx plus dx.
Oh my god.
Yeah.
I was saying question B, but I gave question C. Oh, this will be long.
Okay, must do one by one. Okay. Oh god. Okay. X cube plus 2x squared dx plus x dx squared plus x squared dx plus 2x dx squared plus dx cube. My god. Okay.
Oh.
Okay. Combine everything. Can you okay. X dx square. Okay, 2 times plus 1 3x square dx plus 3x dx square, okay, plus dx cube. Okay, minus 1. So this one is gone. So you get 3x cube. So dx plus 3x. Hold on. It should be delta x equals to 1, is it? When you change to dy dx. Is it?
Delta x.
Ah,
Wait.
you
Did I tell
you
you the limit? Wait. Delta x is 1. Usually we assume
is it?
delta x go to 0, right?
Uh-huh.
The last part lah before we solve.
Ayo. Oh, okay. Sorry, I'm stupid. 3x square plus 3x delta x plus delta x square. Okay, correct. Then dy dx, delta x is 0. So 3x square plus 0 plus 0. Hmm. Nine x square.
Yeah, correct. So
Very long lah. Oh my god.
because the power is too high, you have to group
Yeah,
it
yeah.
to square and power 1. That's why it came very long.
Mm-hmm.
So I think this is the hardest SPM can go. I want it to go harder, I think. But the concept is still the same. You have to group it to power 2 because our knowledge is until expanding power 2. With power 3, it's higher level already. That's why the power they give, you have to always group it into power 2 and then power 1. So
Yeah.
how we do it is actually like this. So we always add delta y here. And then the x, we always add delta x cube. So from the cube is where we split from here. So equation 1, equation 2. So we will take 2 minus 1. So y will go up. And then we will get delta y is 3x plus delta x cube minus 3x cube. So that's why it's long. So delta y will equal to, so now we have to split this bracket here because it's the power 3. So power 3 is a combination of 1 plus 2. So that's why we split it into a bracket of 1 plus 2. So what we will get is 3x plus delta x plus delta x squared minus 3x cubed. So from there, so this one you need to master quadratic expansion, basically this part. So we need to know the form of quadratic expansion. So delta y will be equal to 3x plus delta. Actually, here we can expand, I think. Wait, let me see. Wow. I think don't expand first. Actually, can expand this one. Because I don't like so many brackets. 3x plus 3 delta x. And then make sure the bracket is here because you have to times this after we expand this square. So we will get x squared plus 2 delta x plus delta x squared. So if you want, you can put like delta x in a bracket, not to confuse it. And then here we put a bigger bracket because there is a smaller bracket already. So minus 3x cubed. So we will get, wow. So from here, x squared plus delta x. Actually, you can keep the 3 outside. You times the x inside and times the x inside. Here we can factorize the 3 actually, because it's 3x plus 3 delta x. So you'll get x squared plus 2 delta x plus delta x squared minus 3x cubed. So from here, wait, isn't it the same thing? Delta y equals 3x plus delta x plus delta x squared minus 3x cubed. Okay, x squared plus 2 delta x plus, yeah, correct. So delta y equals 3x plus delta x cubed minus 3x cubed. Okay, is it correct? Is it correct?
Wait, I think so. I'm not sure. But you have to divide with delta x, right? But how do you
Yeah,
gonna
and
do that?
then must divide delta x. So this one here is minus. So I take 1 minus 2. Then delta y. If I take delta y over delta x, 3. Oh, this is the thing, we cannot cancel here.
That's why.
3x cubed. Wow. I think I need to expand here first. This part. Here all is okay. So like how to expand 2 to 3 terms, that's the thing.
You must do one by one. Means first term with the first term, second term with the first term, third term with the first term.
Means like this lah.
Yeah.
Then
Correct.
repeat
And then
repeat lah.
repeat. So at the end you will come out with
6
6
terms lah.
terms. Correct.
No wonder it's so long.
That's why it's very long, but you get the answer at the end of the day also.
Yeah.
But usually question won't ask to do this if the thing is cube lah. Usually square only we expand.
Makes sense. So we will get 3x cubed plus 6 delta x squared plus 3x delta x squared. And then again we continue here, plus 3x squared. Delta x times x squared delta x, plus 6 delta x squared plus 3 delta x cubed minus 3x cubed. So here we can cancel lah. 3x cubed and here. So we will get 6 delta x squared plus 3x delta x squared plus 3x squared delta x plus 6 delta x squared plus 3 delta x cubed. So far, okay.
Yep.
So from here, we need to move the like terms. So here and 3 delta x cubed. Wait, there are no like terms here, right? 6. Here. 6 delta x squared and 3x squared delta x. So we will get 9x squared delta x. So this one settled again. And then that's it basically. Yeah. So plus 3 delta x cubed plus 3x delta x squared plus 6 delta x squared. So it looks more simplified like this. Is it all correct? Yeah. Okay. So from here now we can divide lah. delta y over delta x. To eliminate this delta x. So the whole equation will contribute, we contribute the whole thing. Over delta x. So one by one. So from here we can cut. So we will get delta y over delta x is 9x squared. And then here we will get plus 3 delta x squared. Plus 3 power 3 minus 1 we will get squared. And then here also we cut, we will get 3x delta x. And then from here also we cut, we will get 6 delta x. Yeah, good. So now we will make an assumption that delta x goes to 0. And then we will get, yeah, basically the whole thing goes 0, right? Plus 3, 0 square, plus 3x power 0, plus 6, 0. So you get your answer 9x squared. This one gone, this one gone, this one gone. Done. Oh my god. Why I chose this question? Okay. So yeah, this is the thing on differentiation using first principle. So yeah, that's why this is the hardest question that you can get. So the next thing is first derivative already lah. So now we go to first derivative. Okay, so first derivative. We'll do summary now. We don't want to go through the whole thing definitely. So differentiation formulas. So we go directly to the formula. But that's how we are going to apply in the question. So formulas. Okay, so let's say we have a general form of y equals ax power n. So what will a and n actually represent, you think? In the equation, of course, ax power n.
What is meaning is it?
No, what is the a and n representing?
A is the like the width of the graph, is it?
No, I mean like what we call as a. Usually the question will tell where a and n are.
Oh, I don't know what is it called.
Constants.
Oh.
Numbers lah, basically, because we will put that as numbers. This is general formula lah. Ax n, a simple equation lah. So yeah, they say where a is a constant and it is an integer also lah. Okay, so what we will do is we want to differentiate this. So usually what we will write is like this: d over dx means your d over dx actually represents your y lah. So d over dx of ax power n means in word form is to differentiate ax power n with respect to x. So this is what they are trying to say in the question. So how we do it is actually like this. So what we will get is the thing. So what you get, we just write in terms of alphabet better. So you will get nax power n minus 1. So, or ANX lah, same thing. Means you times the power on top there to the constant, you bring it down. So that's why you get ANX, and then you have to minus the power. So that's one thing you have to remember as well. So, okay. And then the next thing is chain rule. Greatly applied in price index also. So we need to master chain rule here to solve price indexes, especially when they involve 3 years. And then they want you to find a comparison between 2 years, let's say, like something like that. So they said, let's go straight to the formula. dy over dx is equal to dy over du times du over dx. So why they say this is because we can cut the du here and the du here because they are opposite sides of the fraction. So next thing is product rule, the next formula. So product rule formula, you have to remember the pattern now. Product rule, it will be d over dx. The function is uv lah. That's why they put it in bracket. So it's u dv over dx plus v du over dx. So it's opposite to each other lah. When you use u, means on top is dv. We use v, on top is du. So it's opposite to each other. And then this is product rule, okay? And then quotient rule. Quotient actually means what in maths, you think? The word quotient lah. Usually we use quotient as what word? I mean, what operation lah. Usually it's divide, I think, isn't it? The quotient word.
Yeah.
So that's one way to memorize the formula lah. So if you forget how quotient rule goes, you always remember there's a divide sign in its formula lah. If product means product, usually means times, right? So that's why we are timesing here. And then we add up both of these. The bracket like this lah. Okay? So product and quotient rule is v du over dx minus u dv over dx over v squared. So this one, no choice lah. You have to remember the formula. I don't think there's any other way. Yeah, basically the formula speaks for itself lah in this case. Okay, so yeah. And then you have to know is you have to apply it to questions lah. How we apply, when to use this rule or this rule, but most of the times you have to be flexible lah. We can use both. Because sometimes in the exam, we don't know which one we want. So sometimes it might take you to a long way. Sometimes it might take you to a shorter way. So as long as we get the same answer, that's the thing we want. So this is the thing. Next is tangent and normal. Yeah, this is an important concept in this chapter. How to relate between tangent, normal, and a curve. So there's a few processes involved. What kind of curve you want? What shape you like?
Any shape, up to you.
Smile or curve? Smile or cry?
Cry.
Okay. Okay, other size? Okay.
Yeah, okay.
Slightly not symmetrical. Okay. Okay. So the curve sometimes will look like this. Usually the question will involve quadratic equations, like you want to differentiate to linear form. Usually cubic won't involve, because cubic, the shape is a bit crooked, say like up and down. So only like quadratic has like a constant pattern, increase to the max and then decrease. So yeah. So quadratic, let's say I have the function of y equals fx. Let's say. Okay, so if you want to find a tangent, so tangent, what is the most important thing is you must touch one point only. The keyword is one point only. So you have to be careful when drawing tangent line. So let's say where I want the tangent now. Okay, now on top of the peak here, let's say I do tangent here. Because at the peak dy over dx is 0, right? Means my tangent is 0. Simple one. So let's say it goes straight like this. Tangent goes like this. And then normal will always be 90 degrees to the tangent, according to the theory. Oh my god. So it goes down like this, 90 degrees. So this is your normal. This is your tangent. Okay. So the formula between tangent and normal is m tangent times m normal is -1. Tangent, another way, this is a keyword to notice that whenever they say equation of tangent, means dy over dx straight away. This is how we interpret info directly from the words into an equation form. So dy over dx times m normal is -1. M is gradient. So m of normal is -8. Wait. -1 divided times. Wait, m normal will come negative dx over dy. Dx over dy. Yeah. Am I? Yeah, it should be lah, because if you have a gradient here, let's say 1 over 3, right? Means here you have to add a negative and inverse the fraction. So it's -3. That's why here dy over dx, you add a negative and you inverse it. Means it comes dx over dy. So that's the theory behind it. Okay, so that's your normal. I don't want to use the equation in the textbook. You know, summary, right? The textbook gave the last page quite complicated, actually. So we express it in terms like this is easier. Okay, so let me think.
Hey,
Huh?
nothing.
What is 5? Try an easy way to memorize differentiation and integration. Okay, let me think. Sometimes we get confused, right? Differentiation is minus or plus the power, and integration is minus or plus the power, right? So an easy way to memorize is, there's two ways actually here. So one way is the maths way, I call it how to understand what is what from differentiation. One is the maths way. Another one is called the bio way. So if you look at this first, you might think what I'm talking, isn't it? So the first thing, so let's say maths way, right? Modern maths, I mean, not advanced. So how to analyze differentiation and integration concept is, you recall your chapter 4 of modern maths, form 5. Not a favorite chapter, of course, taxation. Okay, so first thing I will ask is, if I say something is general, do you think it's complex or specific? Something general.
Complex.
If I say the word general. I need time to think also. Yeah, that's the way. Okay, so I'll use these words to describe it later. So if I say it's specific, means it's simple. So this is the concept we have to have when we apply this thing. So in the policies, right, the highest one is comprehensive policy, if you remember. And then we go to now I have to remember. Is third party fire and theft, right? The next one.
Yeah,
I think it's
correct.
third party fire and theft. Am I like here missing? Okay, yeah. And then it's third party. And then last one is one, huh? Last one is what was it again? Huh? I forgot the last. Was it base policy?
I also forgot.
Nah, use phone lah and search. So this is an easy way actually to memorize mathematics. Later you show off the site. I think it's base law. Let's say we take it as base law. Just a final check. Is it at the front part or back part usually?
What do you mean?
This policies thing.
I can't remember one.
Wait. Here, wait. Wait, this one tax. Wait, oh my god, it's not tax. It's insurance. This policies is not taxation, sorry. It's supposed to be insurance. So you have loss of property and all that due to fire. So it's under insurance topic, not taxation. Okay, so that's a mistake. Okay, it's here. Let's say it's base law. Okay, so we bring out the concept from here. Okay, so we go this way, right? Up to down, comprehensive to base. So this process is actually called as differentiation. Differentiation is making something simpler. Means from polynomial equations, you go to like a linear equation. So that's why comprehensive is something complex, right? And basic is something like simple, right? So that's why we call this process as differentiation. If opposite means integration, if I go up. So this is one way to memorize. From basic to comprehensive means integrate. From comprehensive to basic means you differentiate. Okay? So this is the maths way. And now, the bio way. Done for bio students, for this one for non-bio students. Okay, so this one, right? If you look at the level of cell of multicellular organisms, right? We got cell to tissue to organ to system to organism, right?
Yeah.
Yeah, one way. So usually the question will ask, right? What is this process actually? The process involved when we travel from year to year. It's actually differentiation. The answer is differentiation, right? So why we actually say it's differentiation, right? Because cell is something complex. Here is something simple. Actually, wait, let me think now. Yeah, because cell is something general, right? We don't have what type of cell it is, let's say epithelial cell or red blood cell or anything, right? But organism is a system already, a specific system. That's why I call it a specific. This one general and simple is not a good way to use it lah. So I say complex to specific. So this process, when we go this way, is differentiation. This process, when I go this way, is integration. So this is another way for you to memorize. From cell to organism, you differentiate. From organism to cell, you integrate. Okay? Good. I think okay lah. And then a last way. So here, like, not good at drawing. So here, so you get like this, right? Yeah, okay. So do you remember this diagram? I think I draw it very well.
It's okay.
You remember what is this? Something in the root of the plant.
Yeah.
Yeah, this one is wood cap thing. It's the wood cap. So we have this kind of zones, right? Okay, here, here, and this is the last. So here is zone of cell division, right?
Yeah.
Here is zone of cell elongation. And then the keyword comes again in the next zone. Why they call it like this? Zone of cell differentiation. Because from here to here, right, this process is differentiation when we go this way. Because, right, when we go from a meristematic cell at the bottom here, right, from here you will get differentiated phloem and xylem tissues at the end, which are specific because they have specific functions. And this is the same to admets. You will get a complex function to a specific function. So that's why here is called differentiation. You go here to here. But opposite means integration. Because you want to integrate the specific cells that have specific functions to a general cell that is actively dividing like meristematic cells located at the root tip. So yeah, this is the sharing that might help. So okay. So this is the thing. Okay. So basically that's it for today. I wanted to end with this so it looks like something interesting. So this is the thing. Okay. Okay, Ryan. I'm going to end already.
Okay. Okay. Bye bye.
Thank you for joining.
Bye bye. Thank you.
Bye.
Bye.
Yeah, stop recording.